Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how you can use the periodic table to find the electron affinity of any atom on the periodic table. Okay, so let's get into this, but before we get into this, remember to subscribe to my channel, hit that notification bell on the top so you can be notified of other videos I put down. Please put comments in the comment section. Let me know what you think. And if you have any questions that I can answer, please hit that like button. Now let's get into this. So we have our periodic table. We're going to set this up so that way we can figure out what the electron configurations are. So the first thing we need to do is we're going to number the sides here. So on your periodic table, along the left-hand side, you will see that the rows are numbered, and we call these rows periods. So in the periodic table, we call them periods. So each period or row has a number. So we're going to number from 1 to 7 on the bottom. So let's go ahead and do that. So if you have your own periodic table, you can number this as well. Yours may look a little bit different than mine, but that's okay. So we're going to put a 1, a 2, a 3, a 4, a 5, 6, and 7. Okay, so we've got those periods numbered. We got the rows numbered. So next, we have to block out certain things or certain parts of our periodic table so that we can recognize them as different parts. You can kind of see that they're different right away, but we're going to kind of highlight the different parts of the periodic table. So let's get some different colors here. Okay, so this first part here, we're going to look at this part here. You can see that this part is kind of by itself. So we're going to color that red. Now, the thing I want to point out is that for the purposes of electron configuration, we'll notice that helium is over here, but we're going to move it over here for the purposes of electron configuration. We're going to put it in this group here. The reason for that is because helium kind of behaves, as far as electron configurations go, it goes over here, mainly because that first energy level that's filled up only has a 1s2, if you remember from electron configurations. So the 1s sublevel can only fill 2 electrons in that sublevel, and so that goes to helium. Helium kind of fits there in this group here. So I'm kind of jumping ahead of myself. So let's kind of put this over here. So we're going to kind of cross this out a little bit. So we're going to move that over here. So we got HE. Okay. So let us kind of color this a little bit, or our outline. We're going to outline this with red. You could pick your own color. Doesn't have to be red. I'm just using red because that's available. But you can use whatever color you want. All right, so that's kind of separated. We're going to now separate the next one, or like highlight the next one. And the next one we're going to look at is this block here. So this block here seems to be one by itself, or it seems to stick out a little bit. So we're going to highlight that a little bit more. So we're going to use blue, or I'm going to use blue. You could use whatever color you want. Okay. And the next one, this part here seems to be a different part. So we're going to highlight this. Okay. And then finally, we're going to highlight this part here. We're going to use orange. So I'm going to use orange here. Again, you can use whatever color you want. You can make it all pretty. Mine's not that pretty. Okay, so here we go. So now I want to point something out to you. So this is going to be mind-blowing. It was mind-blowing to me. So if you've never seen this before, get ready to have your world rocked. So we've learned that in electron configurations, you have the S sublevel. And so you think, okay, so think about how many orbitals are in that sublevel. We only ever have one S orbital. Every S sublevel has only one S orbital. And how many electrons can fit into that one S orbital? 2 maximum, right? So if we look here, how many elements wide is this part here? If we were to count, how many elements wide is that? 2. Okay. So far, so good. Now, let's think about the P sublevel. The P sublevel has how many P orbitals? It has 3, right? You have the px, the py, and the pz orbitals that are oriented in space differently along the axes. And each of those can hold how many electrons each? 2. So each p orbital holds 2 electrons. You have 3 p orbitals. That's a total of 6 electrons. And how many elements wide is this block? If you count, how many do you count? 1, 2, 3, 4, 5, 6. It's 6 wide. Interesting. What about the d sublevel, right? You have the d sublevel. How many d orbitals do you have at the d sublevel? Anyone? Bueller? We have 5 d orbitals. So 5 d orbitals. Each d orbital holds 2 electrons max. And that means you have a total of 10 electrons in the d orbital. And if I was to ask you to count the width of this block right here, how many elements wide would that be? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow. And finally, we have this block here. So remember, we have the F sublevel. F sublevel has 7 orbitals. Each orbital holds 2 electrons. I think you know where I'm going with this. Yes, that's right. 7 orbitals, 2 electrons each, 14 electrons. I think you can guess the width of this block here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Amazing. That is amazing because this table was originally, when it was set up, it wasn't exactly set up this way, but it was pretty much set up this way before we knew anything about protons, electrons, neutrons, right? And so the periodic table, when it was organized, eventually in like 1914, it was organized by Moseley according to atomic number. But before that, it was organized by atomic mass. But atomic number and atomic mass doesn't really change. There's a couple. It's like maybe 4 elements switch places based on they differ based on mass versus atomic number, but it's pretty much this way. So now we have quantum theory. We have orbitals. We have orbital diagrams. We have energy levels, and you could see that the different sublevels match perfectly with the periodic table. That is amazing. I don't know about you, but that just blows my mind. So what we're going to do now is we are going to label the blocks. So since the S sublevel has 2 electrons max and this is too wide, we're going to call that, or they call that, I didn't come up with this. This is called the S block. Okay. Next, since we have this block here is 6 wide and the P sublevel has a maximum of 6 electrons, we're going to call this P block. Next, here, since the D sublevel has 10 electrons max, and this is 10 elements wide, this is called the D block. And finally, since this part here matches with the F sublevel, because the F sublevel holds a maximum of 14 electrons, this has 14 elements across, this is going to be the F block. The F block. Okay, so now we have our periodic table set up, and we've broken up into S, P, D, and F block, and we have our periods numbered. Now, the thing to remember is these periods match up with the energy level that you are at. A couple of things I want to add. So the other thing you want to add here is, I'm going to use orange again. So we have to number these differently here. These rows are going to be numbered differently, and these 2 rows are going to be numbered slightly differently. So for when we're getting into the D block, we're going to have a 3 here. So instead of a 4, this is going to be 3. And these are going to differ by -1. So 5 minus 1 is 4. 6 minus 1 is 5. 7 minus 1 is 6. Okay. And then for these 2, these guys get inserted into here, right after barium, or I should say lanthanum and actinium. So you'll see 58, you get 57, 58, and then this is 89, 90 for thorium. So these 2 rows actually get inserted here. And so when we do that, when we're going from 6 to, when we're doing F, these are going to be labeled, these are going to be numbered, I should say, 2 less than the row or period you're in. So this is 6. So this row here is going to have a 4. So that's going to be 4. And then this row here is going to be in the 7 row, but when we get here, that's going to be a 5. So it's 2 less than the row that you're in. Okay, so we have our table set up. So now you can use your periodic table to write electron configurations. How does that work? Well, let me show you. I'm going to move this over, and we're going to do a couple of examples. Okay, I'm going to use a piece of paper and pen so that you can see it more easily. I'm going to zoom in a little bit so we can see the periodic table. Maybe that's, yeah, there we go. Okay, so that's good enough for now. All right, so here's my piece of paper. All right, let's see how this is done. So the way you use the periodic table to write your electron configurations is this. You first need to know what element you have and how many electrons that element has. We're assuming neutral, so if you're given an element and you want to know how many electrons it has, if it's a neutral element, neutral atom, then the electrons are going to be equal to the protons, and the protons are given to you by the atomic number. So remember, The atomic number is this top number up here. So the atomic number of nickel is 28. The atomic number of arsenic is 33, and so on. So if you know the number of electrons, then all you need to do, remember, the number of electrons are being added to your orbital diagram. You start from the lowest energy level to moving up to the highest, going through the different sublevels. And the sublevels differ in energy as well, right? So the s orbital is lower in energy than the p is lower than the d, and the d is lower than the f. So you're going to fill in the s, and then the p, and then the d and the f, and things like that. So the periodic table actually tells you what to do, because all you need to do is start always at number 1 helium. So you just start at the beginning of your periodic table and you write down the row that you're in, because remember, the row corresponds to the energy level. The block that you're in, the block corresponds to the sublevel, and the number of elements that you go through to get through that block. And that's going to correspond to the number of electrons. So let's do a quick example. Let's do carbon. Carbon, I'll do a simple one here. So carbon is here. Carbon's number 6. Okay, so 6 electrons. So all I'm going to do is I'm going to start at hydrogen here, and I'm going to go through each row, right? Each row until I get to carbon. And I'm going in numerical order. You're going in numerical order. So 1, and then 2 for helium, 3, 4, 5, 6, right? And as I'm going numerically through the periodic table, I'm writing down the row that I go through, the block that I go through, and how many elements in that block I go through. Okay, so carbon. Let's do carbon. So C for carbon. So I start at hydrogen. I got to go through hydrogen. I got to start from 1, and I got to get to 6. So as I'm going through the elements, I am writing down the row, the block, and the number of elements. So I start here. I have hydrogen and helium. I'm going through those because I got to get to number 6. So 1 and 2 are done. So that's row 1. So I'm writing out 1. I'm in the S block, S, and I got to go through 2 elements. So 2. Now I'm done with that row, or I'm here. There's nothing else. So I got to go numerically to lithium. Now I'm in the second row. So that's 2. What block am I in? S. S. And then I have to go through these 2 to get to 6. So I go 3, 4. So I got to go through 2 of those elements. So that's 2. Now I jump over to the P block. Number 5 is next. So I'm now in the P block. I'm still in the second period, second row. So it's going to be 2. And then I put P. And how many elements do I have to go through? 1, 2. So I have to go through 2 elements. So that's a 2 for the P. So that, ladies and gentlemen, is the electron configuration for carbon. That's it. That's how you use the periodic table. Okay, let's keep going. Let's do a larger one. Let's do iron. I like iron. No, let's do cobalt. My last name is Cobalt with a V. Let's do cobalt. So that's going to be CO. Yes, cobalt is my favorite element. Okay, so it's the same thing. So now I have 27 electrons, right? So number 27 means I have 27 protons. I'm going to assume that the atom is neutral. So that means I have 27 electrons. So I'm going to go from 1 all the way to 27. And as I'm going through the periodic table, I'm writing down the period or row that I'm in, the block that I'm in, and the number of elements I have to go through. Because the row, these numbers here, and these numbers here, and these numbers here, right, represent the energy level of that sublevel. And the block here represents the sublevels that you're in. And the number of elements you go through represents the number of electrons you're putting into that sublevel. Okay, let's get into this. So I'm starting with hydrogen, and I'm working my way numerically until I get to cobalt. Okay, so I go through the first row. I'm in first row S block. So 1s. I got to go through those two. So that's going to be a 2. I continue to number 3. Now I'm in the period number 2. That's going to be the second energy level. I'm in the S block. So that's 2s. And I'm going through the 2s, 3, 4. So that's 2. And I jump over now. I'm still in the second row, second period. So that's still a 2. So it's going to be now 2p because now I'm in the p block. And I have to get to cobalt. So I got to go through all of these 1, 2, 3, 4, 5, 6, all the way to 10. So that's going to be 6 electrons in the p sublevel, second sublevel. Now I'm all the way over at neon. So I got to keep going because I got to get to number 27. I'm only at number 10. So keep going. So I go to 11. Now I'm at sodium. I'm in period 3. So third energy level. S block, so that's 3s. I got to go through sodium and magnesium, so that's 2, so that's 3s2. And then I got to jump over again to aluminum. So now I'm in the p block again. I'm still in the third row, third energy level, third period. So that's going to be 3p. I got to go through 1, 2, 3, 4, 5, 6 to get to 18. Again, my goal is cobalt as 27, so I got to go through these. So that's 6 elements, 6 electrons in that sublevel. Now I'm at argon. Now I got to jump down to number 19, which is potassium in the fourth period. So that's energy level number 4, S block. So that's 4s, and that's 2. 1, 2. I got to go through 2 to get to 20. 24 calcium. So 4s2. Now I'm jumping to the D block here. So 20 to 21. I'm in the D block. Notice the number has gone down 1. So that's 3D. Not 4D, 3D. So 3D. And I got to count 1, 2, 3, 4, 5, 6, 7. So that's going to be 7 in the 3D sublevel. And that, ladies and gentlemen, is the electron configuration for the element cobalt. Okay, let's do one more. Let's do a longer one because I want to kind of discuss something here. Last one, we're going to do, let's see. We're going to do, let's do polonium, PO. Or we could do lead. Let's do lead. Let's do lead. Number 82. We're going to do 82 electrons. So lead, PB. So same thing. We have 82 electrons. So we're going to start with 1 hydrogen and work our way through to get to lead. And then that's going to involve the F block, and I'll show you something there. Okay. So we're going to start with hydrogen, 1s2. So we're going to go through the 1s. We go through the 2 elements. So we're going through these 2 elements. 1, 2. 2's there. So we're putting helium there, right? So 1, 2. Now we go down to 3. We're in the second period, second energy. So 2s. We go through 2 elements there. So that's 2 electrons added to the 2s. And we jump over again to the P block. That's going to be 2P. We're in the second period still. So that's energy level 2P. We go through 6 elements. We're going to 82 in this one. So that's going to be 6. Neon, jump down to 11. Sodium, we're in period 3. So that's third energy level, S block, 3S. And we're going through 2 elements. jumping across to the P block here, still in period 3. So we're going to go through these 6 elements. We're in the 3P sublevel. So that's third row, third period, P block, 6 elements through. So that's 3P6. Okay, now we're at argon again. We're going to jump down to 19 for potassium. That's the 4th period. So that 4S, we're in the S block. So fourth energy level, S sublevel. We're going to go through these 2, potassium, calcium. So that's 2. Now we're in the D block, number 21. So again, 3D. So we're at 3rd energy level, D sublevel. So 3D, we're going to go through all 10 of those. So that's going to be 10, 3D 10. Okay. We're going to have to give ourselves some room here. So I'm going to go down here. So after the D block, we go back to 4. I forgot to write that down. We should go back to the 4 here. So when we go back to the P, we're going to go back to the original numbers. So 4, 5, 6, and 7. So here we're going to go from 3D10 to 4P again. So now we're in the P block. We're back at the 4th level. So 4P. We'll write it down here. So 4P. And we're going to go through all 6 elements. So that's 6 electrons. Now I'm at krypton. I got to jump down from 36 to 37, rubidium. So now I'm in the 5th period, which is energy level 5. And I'm in the S block. So that's 5S. So I'm going to 5S. I go through those 2. So then I'm going to be 5S2. Now I'm jumping to the D block again. So that's 4D. And I'm going to go through all 10 of those elements. So that's 4D10. So now I'm at cadmium. And now I'm jumping to 49 with it, which is indium, and that's going to be back to 5. So that's 5P. I'm in the P block again. So 5P. I'm going through all 6 elements to get to xenon. So that's 6 electrons in the 5P sublevel. Now I'm at xenon, and I keep going. So because I want to get to 82, I'm not there yet. So 54, jumping down to 55, cesium, 6th period. So period number 6, energy level number 6. So this is 6S. I'm in the S block now. So that's 6S2 because I got to go through these 2. And now this is where we don't really follow the periodic table exactly. And you'll notice here that lanthanum seems to be in the D block, right? Lanthanum and actinium. And then we're inserting CE after 58. We're not going to follow exactly how this periodic table is. Normally,